In this video, we'll look at how we distinguish among atoms. So the atomic number for an element is the number of protons that are in the nucleus of that particular element. Every element has a different number of protons. It is that different number of protons that will identify a given atom as a particular element. So hydrogen has one proton, and an atom that has one proton is hydrogen. If it had two protons, then it'd be helium. If three, it'd be lithium. Or if it was beryllium, then it would have four. And the number of electrons will always equal the number of protons for a given atom. They'll have no charge. So we're going to begin with just atoms, no charge, equal numbers of protons and electrons, and then as we gain and lose electrons, we'll make ions. Every atom has its own mass number. The mass number is the total number of protons and neutrons within an atom. Because protons have a mass of 1 AMU, as do neutrons, but electrons have so little mass we're going to ignore them. We then can find the number of neutrons by taking the mass number for a particular atom and subtracting the number of protons or subtracting the atomic number of that atom, and that will then give you the number of neutrons that must be in the nucleus also with those protons. So here we see an atom of silver. It has 47 protons and it has a mass of 108. So we know this particular atom of silver has 61 neutrons. We also can rewrite this as shorthand notation by calling it silver 108 because it's redundant to have that shorthand notation on the right there with the subscript of 47 with the superscript of 108, because since it's silver, it definitely has 47 protons, so we don't really need to mention those 47 protons since it is silver. All we need to do is call it silver 108 because we know it already has those 47 protons, has a mass number of 108, so it must have 61 neutrons. There are different isotopes for every element, and those isotopes are atoms that have different masses because of the different number of neutrons, but they still are the same element because of the number of protons. So same number of protons with a different number of neutrons, resulting in a different mass number. Here we see neon. Neon has three naturally occurring isotopes, neon 20, neon 21, and neon 22. And as you see again in that top line, all three atoms here have 10 protons because they are all neon. However, they have 10, 11, and 12 neutrons respectively, hence why they have those different masses of 20, 21, and 22. And they also then have those 10 electrons to balance out the 10 protons, again making them a neutral atom. And just like atomic number, every element has its own atomic mass. When we measure mass normally, like in the lab, we use grams or kilograms if it's really large, but because atoms are so small, we don't use grams, we use AMUs, or atomic mass units, which is kind of like a reset button for mass, rather than, again, using these normal units of mass with grams and all the prefixes of grams, even looking like at a picogram, which is 1/1000th of a gram. It's awfully silly to then think of it in terms of atoms because there's still so many atoms that make up that much. So we use atomic mass units. And the atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. Carbon-12 atom is made up of 6 protons, 6 electrons, and 6 neutrons. So taking 1/12 of the 6 protons, 6 neutrons, 6 electrons, again, gives a good average mass of how we will determine the mass of a given atom and things on that microscopic level. The atomic mass accounts for the fact that these atoms have different isotopes, but they're found in unequal proportions. Looking at the neon that we just saw, well, 20 and 21 and 22 being the three isotopes in which you find neon, the average of those numbers would be 21. However, they are in unequal proportions, so it's a weighted average, accounting for the fact that we find some isotopes in much greater abundance than others. And again, in neon's case, well, the average of his three isotopes is 21, but the weighted average is actually 20.18. Because there's so much neon 20 relative to neon 21 and neon 22 that the atomic mass ends up so much closer to 20. So to find the atomic mass for a particular element, you can take the mass of each of the isotopes, multiply it by its natural abundance as a decimal, and then add those products together. That will give you, again, the weighted average for those isotopes. So we'll take a look at magnesium, and how can we get magnesium's atomic mass? Magnesium is found with, just like neon, 3 naturally occurring isotopes, magnesium 24, magnesium 25, and magnesium 26. And the relative abundances for those 3 isotopes is 79%, 10%, and 11%, again in that order respectively. So what is the atomic mass for magnesium? So I can't just take 24 plus 25 plus 26 because they're not found in equal proportions. If it was 33% for each, you could, and then obviously the average would be 25. However, they're not in equal proportions, so we have to account for that. So to solve out problems, I like to list out what we know and what we don't know. And again, we know that we find magnesium 24 at 79% in nature. We find magnesium 25 at 10%, and we find magnesium 26 at 11%. And we're trying to figure out the atomic mass. And again, to get the atomic mass, you take the mass of that isotope times its relative abundance as a decimal, and then add up all those products. So first we'll take magnesium 24. Again, we find it at 79%. So 79% as a decimal is 0.79. So 24 times the 0.79, and we get 18.96. They'll do the same for the magnesium 25. So take the mass at 25 times 10% as a decimal, 0.1, and we get a product of 2.5. And then lastly, for the magnesium 26, 26 times 11 as a decimal, which is 0.11, and its product is 2.86. And then we can add those three together. We find the atomic mass of magnesium to be 24.32, or the weighted average of those three isotopes to be 24.32. So the average magnesium atom, as I would find it in nature, has a mass of 24.32. So this information, both the atomic number and atomic mass, can be found on the periodic table. The periodic table is an arrangement of all the elements, and they're actually put together in a very particular order based upon their atomic number and upon these repeating properties of these different elements. And when they do that, they're put together with these horizontal rows, which are called periods, and these vertical columns, which are called families or groups. And again, there's a lot of repeating properties, both chemically and physically, that we see amongst the elements as we work our way across these horizontal rows and up and down these vertical columns. We'll take a look at that more further in the future.